Smart energy meter. What's the first thing that comes to your mind after hearing this word? Do you think there will be a meter equipped with sensor and digital displays evolved from those analog coil based meters? Or a meter equipped with Wi Fi, email, and messaging services like a smartphone or other smart devices available these days? Or a meter smart enough to detect when the user is trying to bypass the measurement unit so it can punish them? Now let's compare the developments in the field of energy meters. In the late 90s, electricity board used to install the meters with the coil and rotor based mechanism for measuring the power consumption, which are now replaced with digital meters with sensors and memories which can store the data and also capable of recording faults or any attempt to bypass it. But what is lacking in these is that meter readers have to visit each and every house for generating the bills and later records are maintained in the offices. But to overcome such problems and improve bill collection system nowadays, prepaid meters are in trial. In those meters, each unit is connected to the servers for the maintenance purposes. But establishing such a network in a country like India is not feasible. Such connectivity cannot be provided at all locations for their functioning. So now let's have a look on what we have attempted to do. We have made energy meters that are capable of creating their own network for the purpose of communication. These meters are installed at every house in a locality which will be interconnected with each other and share their data. And at last, this data will reach up to the power station. By implementing this, we may overcome the issue of connectivity.
Now let's have a look on the components that we used in our project. First one is ACS 712. It is a fully integrated Hall effect based linear current sensor. It is simply put forth as a current sensor that uses its conductor and measure the amount of current applied. Now the second component that we used is ESP8266 serial Wi-Fi wireless transceiver module is self-controller SoC with integrated TCP IP protocol stack that can give any microcontroller access to your Wi-Fi network and capable of either hosting an application or offloading all Wi-Fi networking function from another application processor. Third one and the last component, LED interface I2C, is a 16 by 2 I2C interface LCD which is used for displaying variable parameters. As you can see, the meter is stabilizing the connection with the other unit. And as you can see, it is displaying 0 units. That means currently no load is connected to the output or no power is available. Each user is assigned a unique customer ID which is used as a primary key in our database. As we have seen that no load was connected to the meter, so 0 units are being updated on the Google Sheets, which we have used as our database. Now we have connected the output to the load which can be seen on the LCD display and same is being reported on the Google Sheets. This the user interface developed for the management of the power system. Live data updated on the interface with total consumption, top defaulters and other useful information. Since it is in demo mode, we have not worked upon change of rate feature which can be done as and when needed. We can generate the bills and send them to the user's registered email ID, which is demonstrated here. We have provided the same email for both the users in the demonstration, so bills received on the same email.
Till now you had a look on working of our project. Now let's dive deep into the modules and have a look on how things are being managed at the heart of the unit. Let's begin with the core, running on the module which is acting as a server. First, we imported certain libraries which was responsible for handling the certain operations and the devices. Then we created an instance LCD for handling the LCD. Then we defined the static IP, gateway and subnet with the desired SSID and the password which are used to access this server from the client. Then we define certain variables which will handle the updates that are received from the client side. Here we have provided the SSID and the password of our Wi-Fi which is connected to the internet. Then we define the host, that is google.com, and the port for connecting to the Google Sheets. Then we define the guest ID of our Google Sheets which is acting as a server in our case. Here we have defined certain variables which are responsible and used in the power measure. Here this variable millivolt per ampere equal to 185. It is indicated that on the sensor that we have used, that is which is ACS 712 5 ampere version of it, it keeps 185 millivolt as output when there is a current rating of 1 ampere, which is used for calculation of current that is being passed through the sensor. Now let's have a look in the setup function. Firstly we started the LCD, then entered welcome on it, then started the module in the station and access point mode, that is it is acting as both client and hotspot with the previously provided gateway and IP static IPs, and assigned the SSID and the password which were given earlier. Then we directed the server to the two functions, handle index and handle update. Handle index is the function. Let's have a look on the handle index function first. Here at the handle index function we are just returning a simple text as a units that are being used, which means that when this IP is triggered in the browser, it will display the current units that being reported from the client at that time. That is being handled in this update. Then the another function, handle update. Let's have a look in the handle update function. Here we have read the argument that are being passed from the server to the server from the client, and we received those argument in unit C and IDC variables. That is, we have received the ID and the units from the client, and then we returned updated to the client. Later on we added these parameters to the string v1 and v2 and created a URL which is responsible for sending the update to the Google Sheets and pushed that data to the Google Sheets here. Now let's move to our setup function. we were here. Then we have started the server and printed the result on the LCD itself. Then we have connected to the Wi-Fi for accessing the internet with the provided station ID and station password. Now let's enter in the loop function. First we have called the get VPP function, which is get voltage peak to peak. Let's have a look on this function. Here we have initialized certain variables, then we read the value that is being returned at the sensor in pin, which we have earlier defined as the A0 pin, and we have read the maximum and minimum value and then divided it by 1024, which this calculation was performed to get the voltage from peak to peak. As we know, in a AC circuit the sine wave is formed, and we have calculated the distance from the crest to the trough and return the result to the voltage peak to peak variable in the loop function, and we divided that function to calculate the amplitude of the wave. Later on we have calculated the voltage RMS, that RMS value of the voltage that is being passed through then we calculated the IRMS current IRMS value and divided the voltage per ampere, that is how much ampere current is being passed, as we have earlier defined that the sensor returns 185 milliampere per ampere. That is, when 1 ampere current is passed, it returns 185 milliampere. And this 0.07 was the calibration factor. That is, when the sensor is not connected to any output, it was still showing 0.07. So we have neglected and corrected that zero error, and we have stored the units to the units function and printed that result and the customer ID to the LCD and check the connection status, then whether we are still connected to the Wi-Fi or the connection is lost. If the connection is established, then we have added those values to a string and created a URL and pushed that URL to the Google Sheets function. Google Sheets functions. Then we have printed the request sent on the serial monitor and the such result also displayed on the LCD. And this complete our code which is running on the server side. Now let's have a look on the code that is running on the server side. Firstly, we imported the library for handling the Wi-Fi and the LCD. Then we created the instance LCD. Then we provided the host and the SSID and the password for the server side that we have created in the server code. These are the variables same as the server side code, responsible for the measuring the power and storing the units. Then enter the setup function. Firstly, we started the LCD and printed welcome on it. Then we connected to the Wi-Fi with the provided SSID and the password, and checked the connection status and made sure that the client is connected to the server and printed the result on the LCD. Then we enter the loop function. Here we are just measuring the power as explained in the server side code with the get PP function and the other calculations involved which were explained earlier. Then we check the connection status to make sure that our request is being succeed. Then we send the request at the port number 80 to the host with the parameters, ID and the units. And then printed the result on the LCD. Here this is the get VP function, that voltage peak to peak, which we have explained in the server side code. As you are aware of the code that is running on the modules for handling the updates and sending them to the Google Sheets. Now let's have a look on the code responsible for the UI, which is developed in the Python language with the help of the tkinter module. Firstly, we have imported the tkinter modules and certain features. Then we have imported the pandas for handling the Sheets operations. Then we imported the eSpec library, which is responsible for accessing the Google Sheets remotely. Then we imported the SMTP library, which is responsible for handling the emails. Then email master library, which is responsible for creating the emails in the desired format and date and time. for accessing the date and classifying the data consumption based on days in months. Then we have created the root window of the software with the desired width and the colors. Then we have defined certain variables for the handling the values. Then we have defined a function gets the data. Here we are accessing the sheets, that is our server sheet to be acting on the Google file. Then we have defined the update label function. Here we are updating the using data that is being displayed live on the software screen. The other parameters are being displayed. Here we have been given the function the change state button, which we have disabled for now. Then we have defined the function for generating the bill. Here we are generating the bills and sending this email with the power management system as a subject to the users on since it is in a demo. So we have provided only a single username to single email to both the users. Here we have connected to the server to SMTP library and send the mail and the message displayed on the screen via message box. These are the certain other functions and the parameters for displaying on the software. Here these are the certain other parameters which we have created for the UI. Thank you.